Alright, let's look at the homework 2.5, problem number 7. Alright, so we have this piecewise defined function, and we want to look at the discontinuity, and we want to see if it's continuous from one side. Alright, so you have a, since x plus 4 is the first formula, which is a linear function, so it's continuous by itself. And 1 over x is continuous as long as x is not equal to 0. Looks like its x is between 1 and 3, so it's fine there. And the square root of x minus 3, as long as x is greater than or equal to 3, this is continuous. So all three pieces by themselves are continuous, right? Then discontinuity can happen between the gap between those pieces. So for, there are only two places. When x equals 1 is the gap between the first one and the second one, and x equals 3 is the gap between the second one and third one. So let's look at those places. Actually, they're looking for smaller values, so this is going to be 1, and this is going to be 3. Right? So we're going to see the continuity. Let's look at 1. Right? So if you look at the limit of this function f of x, say as x approaches 1 from the left, right? So in this case, since you're approaching from the left to 1, so you have to use the first formula. So you have a limit of x plus 4 as x approaches 1 from the left. Alright, but since this is just a linear function, so it's a plug it in. 1 plus 4 is going to be equal to 5. Right? Then you compare that with f of 1, right? But the 1 is included in the first formula, so it's again, this is going to be 1 plus 4, which gives you 5. So we have equality between those two guys. So we can see that at 1, it's continuous, at least continuous from the left, right? So if you look at the right, right-hand limit of f of x as x approaches 1 from the right. So in this case, we are approaching from the right. So the graph we're looking at is actually 1 over x. So we have 1 over x. So if you, as x approaches 1, so 1 over 1, which is going to give us 1, right? So which is different from f of 1. So it's not continuous from the right, right? So it's continuous from the left, but not from the right. So let's answer that, and continuous from the left, right? So we have that. Then at 3, we just basically do the same thing. Right? Limit of f of x as x approaches 3 from the left. Right? So in this case, we still have to use the second formula. So it's a 1 over x as x approaches 3 from the left. But this is going to be 1 over 3. So it's a 1/3. Right? Compare that with f of 3, right? 3 belongs to the last one, so we have to use the last formula, which is square root of 3 minus 3, which is actually 0, right? So this is not equal to f of 3, which means that it's not continuous from the left. How about from the right, right? So if you do a limit f of x as x approaches 3 from the right. In this case, since you're approaching from the right of 3, so it's we have to use the last formula. So limit of square root of x minus 3 as x approaches 3 from the positive side, from the right. And then you have square root of 3 minus 3, which actually is 0. Which matches the function value. So which means that it is continuous from the right, right? So we go here, and it's continuous from the right. Oops. Right. Then we just have to find the picture here. Alright, so looks like x plus 4. Alright, so this one, first one you have the right one, so second one's not right. And let's see, third one, fourth one has the right picture. Alright, so second part, between 1 and 3 we have to get 1 over x. So let's see, this one, it doesn't stop at 3, so this one we already eliminated. Here, it's between 1 and 3, and it has that, and the same thing over here. So it's going to be between the last two. Alright, then if you look at the square root of x minus 3 would look like this one, right? So this has to be the third one. This actually goes in the negative side, so it's not going to be right. Alright, so that should be the right picture. Alright, let's check submit for testing. Alright, it came back and we got all these parts correctly. Alright, that's it. I hope that this was clear.